We continue with our discussion on capacity, demand, time formulation of component reliability problems. Let's review what we have covered so far. In case 1, we considered C and D, the capacity and demand, or more generally the basic variables of the problem, as time invariant random variables. And in that context, we learned the first order reliability method, the second order reliability method, Monte Carlo simulations, importance sampling simulations for computing failure probabilities. In case 2, we allowed the capacity and or demand to vary but non-randomly in time. And we then moved to case 3, where the loads first in case 3a occurred as pulses with random magnitudes that were identically distributed and mutually independent, but these number of pulses were known in a given time interval. Then we relaxed that assumption and allowed the loads to occur as a Poisson process. So not only the magnitudes, but the number of and the time of occurrence of these loads were also random. We did not consider any aging at first, but then we introduced aging as well in case 3c, but that aging was deterministic, not random. I have been asked that is it not possible to bring in random aging as well, and that's why I have included case 3d, where the loading process is Poisson, the load magnitudes are IID and independent of the strength type variables, but the aging can be random in nature. There is nothing in the formulation that restricts us to do that. The main reason that I was looking at case 3a, b, and c was to show that there are closed form solutions to those interesting problems. But let's also look at case 3d, and we will solve one example with that. And finally, we will look at case 4, where C and D are both random processes with one restriction, that they are stationary in nature, and I'm going to define what that means, and then see under some specific assumptions how we can define the reliability in that case as a first passage problem.